This month, we're having a Quality During Design Redux. We're pulling 4 episodes from our 2021 archives about test results analysis. In a more recent episode, released March 29th, titled The Fundamental Thing to Know from Statistics for Design Engineering, we talked about hypothesis testing, how it's used for lots of data analysis techniques, and why it's an important responsibility to understand a little more about them. Our Quality During Design Redux episodes are taking the next step from that. So far, we've revisited sampling, competing failure modes, distributions that are not normal, and let's wrap up this series with statistical versus practical significance. I hope you enjoy this last episode of this installment of the Quality During Design Redux. When we're looking at results like measures of a characteristic, we need to take care not to get too hung up on what the statistics is trying to tell us. Yeah, statistical tools are a good way for us to make decisions, and the results can act as proof for us. But there's a practical engineering side to results too. We need to evaluate the statistical significance along with the practical significance. I'll tell you more of what I mean after this brief introduction. Hello and welcome to Quality During Design, the place to use quality thinking to create products others love for less. My name is Diana. I'm a senior level quality professional and engineer with over 20 years of experience in manufacturing and design. Listen in and then join the conversation at qualityduringdesign.com. I had some great mentors when I first started doing quality engineering type analyses. One of the first lessons I learned was the difference between statistical significance and practical significance. I was evaluating test data. I think I was comparing two things. We were modifying a manufacturing technique, and I wanted to find out how that change affected the product. I wanted to learn if the performance of a quality characteristic had changed. Did the change have any effect? And if it did, was it worse than before? If it was no worse than before, then we'd go ahead and make that change. I designed the test and asked parts to be made. Then I did a comparison using statistical hypothesis testing. My results showed that there was a statistically significant difference between the two manufacturing methods, that the performance had gotten worse. These results indicated to me that this change had a bad effect on our product and that we shouldn't make that change. When I reviewed the results with my mentor, he said, even though the statistical comparison concludes that the new method is worse, from a practical standpoint, it's negligible. I think this change is okay to implement. We then had a good discussion about statistical versus practical significance. Here is what the NIST Engineering Statistics Handbook has to say about this. It's important to distinguish between statistical significance and practical significance. Statistical significance simply means that we reject the null hypothesis. The analyst should not just blindly apply the test, but should combine engineering judgment with statistical analysis. My thoughts about it are this. We use tools to help us make decisions and predict outcomes with some confidence. Some of the techniques are a way for us to apply a mathematical model, like statistics. Some are graphical organizers, and others still help a team of people organize and coordinate their ideas. They're all tools for people to use to make decisions. Ultimately, we use the results of many inputs in order to make our best decisions. When I did my statistical comparison test, I got results that showed that the change in manufacturing had a negative effect to the product performance. The parts made with technique A were different from the parts made with technique B. The product is likely to perform worse with technique B, more than just a matter of chance. But when we looked at the data compared to the larger performance requirement, we decided that the negative change to the performance was minuscule. We looked at the engineering aspects of the part, its requirements, its purpose in the whole system, and all aspects of the data we collected, like the failure modes and the range and location of the data. And we considered the reasons why we were making the change to begin with. When we put everything into context, we felt we had enough information altogether to conclude that we're going to go ahead with the change. How did I capture this decision? I wrote it in a report. I showed the results of the statistical test as they were, showing a statistical significance. I also put the results in context with the bigger picture, then concluded that we were going to go ahead with the change. There's no need to ever hide results. In fact, omitting the results of the analysis would have been a bad practice. We show all the results and explain our decision. If it doesn't make sense to others, then maybe we're not making a good decision. What's today's insight to action? Let's use all of our data and analyses and our engineering know-how to make decisions. Realize that statistics is a tool, albeit a powerful one, but it's just one tool to use when we're making decisions. A result can show us that there's a statistical significance, but maybe it's not a practical one. Please visit this podcast blog and others at qualityduringdesign.com. Subscribe to the weekly newsletter to keep in touch. If you like this podcast or have a suggestion for an upcoming episode, let me know. You can find me at qualityduringdesign.com, on LinkedIn, or you could leave me a voicemail at 484-341-0238. This has been a production of Dini Enterprises. Thanks for listening.